I'd like to welcome Raymond from Cilium, and he's gonna give a talk about some Cilium cluster and service mesh things. So over to you.
Thank you. Good afternoon, everyone. I hope you had an awesome lunch. Also, everyone online, welcome to this session. How many of you were at KubeCon or attended KubeCon online? Quite a few. So when I submitted this talk, I called this Connecting and Securing Clusters Across Clouds with Cilium Cluster Mesh and Service Mesh. But after KubeCon, I could also call it just Cilium Mesh. So in this session, we'll talk about what Cilium Mesh is, what the roadmap we have, and there's some awesome stuff coming. My name is Raymond de Jong. I'm field CTO for the company called Isovalent. And I'm happy to be here, so also thank you for the organization for arranging all the things and to have me last minute as well. I have a lot of stuff to go through, and if the demo gods are with me, I also have a little demo, and obviously also time for some questions. Later today, I also have a workshop, so if you want to get some hands-on experience with Cilium, attend that workshop. We go through a hands-on labs, and you can earn a badge as well, which you can proudly share on LinkedIn. So let's get started. How many of you have heard about eBPF? A bit more. So we have a bit more people learning about eBPF. So today, I'm not going deep dive into eBPF, but more likely about Cilium and Cluster Mesh and Service Mesh and how you can combine them together. Obviously, Cilium and eBPF are both open source projects founded by the company behind Isovalent. We originated it and we open sourced it, and we're still contributing and maintaining as such together with the community. And Isovalent as a company also has a Cilium Enterprise release for enterprises. Today we'll focus on open source, obviously, so everything you will see is available in open source. eBPF stands for Extended Berkeley Packet Filter. That doesn't tell you a lot, but what it basically means is that we make the kernel programmable in a dynamic way. We like to say what JavaScript is to your browser, eBPF is to the kernel. For the context of today, this means that we're focusing on kernel events where we can attach eBPF programs on. So think about sending a packet on the wire. We can get metrics using eBPF. Connecting workloads together, a pod sending a packet, opening a process, or opening a socket, sorry. That's also an event where we can attach eBPF programs to. And using that technology, we can run in kernel, high speed, high performance, and do such things such as security, observability, and networking. So Cilium is built on eBPF. You don't have to be an eBPF expert to run Cilium. Cilium is programming the required programs on the nodes, depending on the configuration you set, to do its magic. This is the 30,000 view of features Cilium can do today. Obviously, all the networking features. On top of that, observability with Hubble, which I will show in the demo as well. And Service Mesh released last year. We have a ton of features already available with Service Mesh, such as Ingress, Gateway API. MTLS is on the roadmap, but we already support encryption. Tetragon is also part of Cilium that provides runtime security. I'm not going to talk about that today. That's a whole different topic. But we have some awesome resources online as well. Cilium runs on any cloud, any compatible Linux operating system. The main requirement is a fairly decent kernel, 4.9 or later, and you're good to go. On cloud or on-prem, on OpenShift, or even Debian managed by yourself. VMs, obviously, as well. What's different with Cilium is that we have the concept of identity-based security. So the goal here is not to trace IPs. IPs in Kubernetes clusters are ephemeral, they change all the time, and at scale it's untrackable, untraceable to troubleshoot. So we use the notion of identity-based security, which means that each unique workload, meaning each workload with unique set of labels, the metadata you create on your deployments, for example, will result in a unique cluster-wide ID. So if you have a deployment called front end with the label front end and a deployment with the label back end, we use that metadata to create those unique identities, and we use it throughout our features in Cilium, also for observability, metrics, and obviously security. So in this case, the front end wants to talk to the back end. This is allowed by network policy, but using eBPF, we're able to attach this identity to the data plane, and we're able to inspect that identity. And we're also able to observe flows for that given identity. And this concept is the core of Cilium and how it's different compared to other network providers. Additionally, Cilium provides layer 7 security capabilities. So beyond standard Kubernetes network policies supporting layer 3, layer 4, which we also support, we also have the concept of Cilium network policies, which allow you to have layer 7 security. So you can specifically allow a specific HTTP call or method on a specific URI or URL. How it looks like is using HTTP rules in, for example, Cilium network policy. So in this simple example, I'm only allowing a GET method on the public URL. And we also support protocols like gRPC, Kafka, Cassandra, and others. Cilium also supports DNS-aware network policies. This allows you to create 2 FQDN rules. And this is super useful in cloud. For example, when you want to secure access to S3 buckets. You may know that underlying IPs of those kind of objects change a lot. So using instead 2 FQDN rules makes it manageable to secure access to such resources. And here's a simple example where we match a wildcard.mydomain.io, but you can also do specific domains, a list of specific domains, and also regex. Now it's time to move to Cilium Mesh and how we use this construct across clusters in the cloud. We started with Kubernetes networking. We then introduced Cluster Mesh, which is already available for a few years. We have the external workload capability where you can run a Cilium agent on a VM. But we're now also introducing hybrid multi-cloud networking with the so-called Cilium Transit Gateway. This is the big picture what our vision is. So we already support multi-cluster networking using Cluster Mesh, which I will demo today. We already have egress gateway capabilities, which allow you to have predictable outbound network connectivity with specific IPs, where you are able to secure those IPs with your external firewalls or in the cloud. We already have ingress capabilities, such as service mesh ingress, gateway API. So we can also attract traffic in the cluster with native load balancing and BGP capabilities in Cilium. But what's new here is the announcement of this transit gateway. And the goal here is that you run this in the cloud as an appliance on a VM, for example, where you can attract traffic, for example, from a VPC or a function or whatever is running in the cloud, maybe EC2 instances and such, and get them in the Cilium data plane. They will get this unique identity I mentioned before. And this allows us to connect this all together using the Cilium Mesh. So you may have an on-prem cluster with OpenShift meshing with Azure cluster running in the cloud. You may have egress, ingress in those clusters. And now we are able to, for example, on AWS, import a VPC network to be able to be meshed in the Cilium data plane. And also, for example, on-prem VMs can also be meshed. So you can get this unified security and observability across clouds. So let's dive into Cluster Mesh. So Cluster Mesh is the capability where you can connect multiple clusters together, independent of location. The only requirement is that you have layer 3 connectivity between the cluster nodes. That means that you may use a VPN or other constructs to connect your clouds or data centers together. Once you've done that and install and configure Cilium with Cluster Mesh, you have a unified Cilium data plane. Each cluster learns about the workloads running in the other clusters, and then you are able to do the load balancing across clusters, service mesh, network policies, the observability, and so forth. I mentioned before this identity-aware construct. This is also used in Cluster Mesh. So each Cluster Mesh-enabled cluster has this read-only entry point in other clusters to learn about the workloads in that given cluster. And that allows us to create network policies or to get metrics or observability across clusters for your workloads. What can you then do? So first of all, you can use east-west load balancing, high available across clusters, using services, so just cluster IP type of services with annotations. And this allows you to have high available workloads across clusters. And this means that if a backend or all backends fail in a given cluster, traffic will fail over to other clusters. But you can also use it in a shared services topology, for example, where you have a shared infrastructure cluster and you don't want to maintain for each tenant, for example, all these kind of infrastructure services, but instead you can expose this centralized service into your tenant clusters, and Cilium will know how to route traffic to that given cluster. A bit similar, but obviously a different concept, is that of splitting services. This is, for example, useful in telco, where you have smaller edge clusters. They don't have data stores to store all the metrics from their subscribers. So you can then expose a data store service to a centralized data store service running on a centralized cluster, and Cilium will learn how to forward traffic. Also, you can manipulate the service affinity. So topology-aware routing is what we like to call it as well. This allows you to contain traffic within a given cluster and only load balance traffic to another cluster when all endpoints in the same cluster fail. And obviously this has a benefit in terms of latency. If you run a VPN between clouds, you don't want to have this random load balancing across, but instead you want to contain it in its local cluster. Unless endpoints fail, then traffic will be load balanced across the other cluster. You can also annotate the service with remote service affinity. This will work the other way around, and this is useful for example, temporarily lifecycle upgrade workloads in a given cluster. Once you're done, you remove the annotation and the load balancing is back to the state before. How does it look like? So I explained before, just a simple cluster IP service with global service and service affinity annotations. So depending on what you need, you would just annotate a given service in each cluster in the same namespace, with the same namespace name, same service name. And Cilium will then learn about the endpoints in each cluster and load balance accordingly. And this is an example of the remote annotation. Additionally, you can secure traffic across your clusters using Cilium Network Policies. Because we have meshed them, Cilium is aware about these identities in each cluster. And in this case, we have, for example, a Rebel base and an X-Wing workload. And in this case, we only allow ingress traffic from the X-Wing pod or deployment from cluster 1. And we apply this rule on cluster 2. And this is a simple example of cross-cluster networking and security, but obviously this is super useful with high amount of workloads. Also cluster-wide network policies, so policies applied on the whole cluster, support the notion of a cluster name, and as such you can use it in your network policies. Moving on to Service Mesh. Cilium Service Mesh allows traffic management on layer 7. We allow observability using eBPF already. That's nothing new or special. We already had that capability. But what it adds is, without instrumentation of your application, we're able to expose layer 7 metrics, such as return codes, HTTP duration, latency as such, to provide golden signals to your dashboards with, for example, Grafana. Security in combination with the network policies, with the MTLS features we are bringing, and obviously with the encryption, which we already support. So pod-to-pod traffic is already capable of encryption using IPsec or WireGuard. If you also want to use MTLS and authentication on MTLS, that's coming in the next release in Cilium 1.14, where we just use network policies where you specify authentication is required. And then Cilium under the hood will enforce the authentication before setting up the actual session. So we do this checking, for example, with the Spirey server based on a SPIFFE ID, and we're able to match that ID with the given workload. Hopefully that's in summertime, around summertime, we'll be able to release that and demo that as well. We're not creating a new control plane. So we just bring the resources such as Ingress resource, Gateway API resources, which is currently in beta in the Gamma project, but we already have the capabilities. SPIFFE, and you can also use Envoy CRDs. That's not something I would recommend, but if you really want to, you can do that. And then you have a choice. You can create new clusters, enable Cilium. You have an eBPF native service mesh with Cilium, But if you already use, for example, Envoy-based sidecar implementation, it's also supported to run it with Cilium. It's not mutually exclusive, and you will actually have already some benefits in terms of performance and security as well. What's different with Cilium Service Mesh is that we want to reduce the operational complexity. We want to reduce resource usage. We want to provide better performance using eBPF and the fact that we don't use sidecars and avoid sidecar startup shutdown race conditions and the notion of that you don't have to wait for a sidecar to be available to accept actually connections. So obviously when you don't run sidecars and instead use the Cilium agent with embedded proxy on the node, you will save a lot of resources in terms of memory and CPU, and also cycles you have to maintain for TCP/IP stacks when you run sidecars. Also, latency is 3 to 4 times better, or lower, depending on how you look at it. So latency is 3 to 4 times lower without sidecars, and that's due to the fact that with sidecars, you have to traverse the TCP/IP stack 3 times at least for sending traffic out of a node. Instead, with eBPF, we are able to shortcut this connection on the socket layer directly to the network interface and send it on the wire. This is the case for L3 and L4 traffic, so layer 3, layer 4 traffic. In case of layer 7, load balancing or path-based routing or whatsoever, we have to redirect the traffic to the embedded proxy. And we use, again, eBPF on the socket layer to give it to the proxy. The proxy does his rule filtering, forwards it again on the network. And this already saves a lot of performance and lowers latency. I mentioned already the capabilities, so I will skip through. Ingress, for example, native Ingress resources allows you to create path-based routes and such. So you leverage the embedded Ingress class of Cilium and then create Ingress resources depending what you need there. And this means that you can also use Gateway API, as Ingress V2 is what we are calling it. Or how I like to call it, and that means that you get better capabilities. Ingress has limited capabilities in terms of what you can do. You cannot do out-of-the-box percentage-based, path-based routing and such. Gateway API provides that with simple resources, HTTP routes, and you can attach them to the Gateway API. What's also great about Gateway API is that you have separation of roles, so a platform team can manage, for example, the gateway resources, where an application team can manage the HTTP routes and can attach them to the specific gateway they need to attach it to. How does it look like? So, first of all, you configure Cilium with the gateway controller enabled in Helm, for example, or using command line. Then you create one or more gateway resources. In this case, I have a simple HTTP gateway. I create a listener, and then you can create multiple HTTP routes to attach them to this gateway by specifying the parent reference, and then rules. So in this case, a path-based rule to forward to a specific service on a specific port. You can also do TLS termination, again creating a listener, and in this case, we're listening on a specific host name, mapping it to a secret in that given cluster and namespace. And then we're able to do the TLS termination and attaching the HTTP route, again with the host name, and forward traffic to specific paths and ports. And finally, traffic splitting with weighted routes allows you to do percentage-based routing or canary rollouts, where you introduce a new service and slowly are able to introduce traffic to that new version of your service. Also new is layer 7 load balancing for east-west. So remember the annotations I mentioned before with Cluster Mesh. On top of that, we can support layer 7 load balancing and do things like specific algorithms for gRPC, for example, where we specify least request as an annotation, so we can effectively, based on traffic, load balance traffic across clusters. And that's, again, with simple annotations where you enable layer 7 load balancing and enable, for example, the algorithm least request. And you can combine that with Cluster Mesh. Now, let's say we're leveraging the power of Cluster Mesh with Service Mesh. And that gives you a lot of capabilities. So first of all, you can use ingress resources to attract traffic in your clusters. On the ingress resource, you can make decisions where to forward traffic to, or you can do percentage-based routing. On a given service, you can configure it as a global service. So in this example, I configured the backend service as a global service, so I have high availability of my endpoints across clusters. And you can mix and match these capabilities in your clusters. You can also mention, or you can also use the topology-aware routing we talked about before, allowing you to attract traffic in a cluster, keeping it in the cluster unless the workloads are not available. You can even consider canary rollouts to a new cluster. So maybe you have a very busy production level cluster running. You know there's a new version of your application going to be introduced. Maybe you're not sure about how it's going to impact your cluster. And therefore you can temporarily or slowly move traffic or introduce traffic in a new cluster using cluster mesh. So you don't have congestion, CPU contention and such. Once you're ready or once you're comfortable with what you're seeing, you can flip over all the traffic or upgrade the application as you see fit. So there are multiple ways to do this, but these are just a few examples of capabilities. A quick word about observability, because using these capabilities, we can also use Hubble and Hubble UI to provide all this rich data of visibility across your clusters. And Hubble consists of 3 parts. A Hubble UI, which provides a service map, a namespace view of the workload you're running, the traffic it's generating, the protocols it's using, which I will show in a minute. A CLI for advanced labeling, troubleshooting, filtering, capabilities for exporting that data as well. And finally, Hubble metrics. You may have heard that we are integrating, working a lot together with Grafana to get out-of-the-box dashboards, golden signals without instrumentation of your application to monitor the performance of your clusters and your applications on layer 7. Hubble interacts with Cilium, so it is able to extract flows from the Cilium agents and provide this data either to you on the UI or through Grafana with metrics. That moves me to the demo. So let's see this in action, and hopefully the demo gods are still with me. It was broken this morning, so what I've done, I'm running cluster mesh on GKE, so I have 2 clusters in GKE, running Cilium, configured Cilium using cluster mesh. In this case, I just use Helm, so basically for each cluster I specify a cluster name and a cluster ID. I'm enabling the cluster mesh features. In Cilium open source, you can also use the CLI. Super easy to use cluster mesh with the CLI because it will automatically configure the clusters, takes care of the TLS certificates and such. Then I have deployed, and let me quickly go back to my slides, 2 simple demo applications. So first of all, I have a simple front-end, back-end application, and I've configured the backend service as a global service. And I also have a client workload, which is not allowed to talk to the backend. And I also introduced other namespace for the famous book info application, which I configured with service mesh, so I can reach it from outside on the internet, on an IP provided by GKE, attract the traffic into my application. And I've created the detail service. I've annotated that service as a global service, so I will see load balancing across clusters. All right, so first of all, the Hubble UI. So as you can see, I'm looking at the global service default. This is where I have this little front-end, back-end application running. And we can see live the traffic map from this given namespace, from the front-end to the back-end, and from the client to the back-end. If I click on the front-end, I will get a filtered view of all related traffic from and to the front-end. As you can see, the front-end is talking to the back-end on port 80 and HTTP, and is talking to a back-end in cluster 2. So I also have this notion of the cluster name in my UI, so I can see and confirm it's sending traffic across clusters because the back-end service is configured as a global service. I also see a client component. When I click on that, I will see little red lines, and that will mean that the traffic is dropped. And also the flows below confirm that. And I can see it's dropped, the policy verdict is dropped, and that's most likely because I've deployed a network policy. So as you can see, the front-end network policy is configured as such that I'm allowed to talk to cluster 1, that I'm allowed to reach endpoints on cluster 1, on cluster 2, in this case the backend. And on the backend, the other way around, I allow the front-end to access the backend, applying this policy on the backend, and that means I have no policy for the client, so the client is automatically dropped. Moving on to the book info application, I just wanted to show you that I just annotated the detail service with the global service equals true. So let's see what's going on. I need to generate a little bit of traffic on my book info. So as you can see, I'm reaching it on a public IP. This is actually running as well an ingress resource to attract traffic in my cluster. And I need to generate some more traffic. And do this for a bit. And this, yes, all right. So in here now I'm seeing a book info namespace. And this map has more services running, so it looks a lot more interesting. And as you can see, I see traffic from world, and sometimes it's also mentioned as ingress, but in this case, world, reaching my review service. And I also see the product page, talking to other services. And more specifically, I see details. I see cluster 2 and cluster 1. So I'm seeing and confirming that I'm load balancing traffic across clusters. Potentially, I can configure my application to run it across clusters for all services, but this is just a simple example to keep it simple, and only the detail service is high available across clusters. All right, so going back to the slides. That concludes my demo and almost my session for today. If you want to learn more, there's a lot of cool resources out there where you can learn hands-on or reading the documentation, how to get started with Cilium. On the isovalent.com/labs page, we have a lot of, I think, 21 labs already, where you can test Cilium, Tetragon, and all related features, hands-on, including Cluster Mesh. On the community side, we have a Slack channel. Feel free to join, ask questions. We're all there to help. You can find the documentation on cilium.io, also with getting started guides for GKE, Azure, and so forth. If you're more interested in the core technology of eBPF, feel free to check out eBPF.io. We also have this awesome ebook available for you to download from Liz Rice. She is very good in explaining in simple words how this works, so I really recommend that to learn more. With that, I'm concluding this session. Thank you for having us. Thank you for being here. We have a workshop in half an hour, so feel free to join if you want to. And I'm open for any questions. Well, thank you.
Any questions for a presentation? And yeah, if we got some questions here in the audience, we finally have a mic. So please raise your hands.
I will shout, so don't worry. So I think this is an obvious question. And especially when you're talking about sidecar, so what's your take on the ambient mesh, which is being announced?
Yeah, ambient mesh is following the same route as Cilium has taken. I think it leverages the Z-tunnel capabilities to do that. So it's not fully eBPF in that sense. So in that sense, we're different, but they do follow the same approach. So it's a matter of your requirements, what's best for you. Yeah.
Well, when I tried with with meshing clusters. As you mentioned, the Cilium is learning from cluster. And maybe I'm wrong. The Cilium is learning about cluster connecting to etcd. Am I right? Why, actually? Why not using Kubernetes API, but you are connecting directly to etcd? It's just curiosity.
That's an engineering question, I would say. That may change as well. I think even that there are different capabilities to configure it if you want to. We do need to keep track of all the identities which are configured to leverage the cluster mesh capability. So we need some kind of key value store to track that and to make that accessible, so such that another cluster can learn about that identities. So we only expose those identities. So if you think about it, we're not exposing all workloads in a given cluster, only the cluster mesh enabled ones, if that makes sense.
I was just curious. It's surprising.
Yeah. Well, this is a very deep level engineered decision-based question. I would recommend, feel free to ask this question on the community Slack, and we have the engineers there happy to answer that. But this is how far I know it. Good question. Any other question?
Yeah, maybe not in the audience. We have questions on the Slido.
Oh, cool.
So the first one. Yeah, the Cilium L7 proxy linkable direct to the binaries.
Are there any plans for any?
Are there any plans for any library for
Not
that?
that I'm aware of, but I can check any library level. Not that I'm aware of, no.
Okay. Well, maybe we'll try to figure it out and
Yeah.
maybe answer that later.
Any gotchas using Cilium on-prem bare metal installations of Kubernetes? No, not any gotcha. The only requirement is a fairly decent kernel. So 4.9 or later is more than enough for using Cilium and Cilium Cluster Mesh.
And the last one about the managed certificates for encryption.
No, we're not having a built-in CA as such, right? So what we are looking into is if we can integrate with Cert Manager or other solutions for managing the lifecycle of certificates with Cluster Mesh. Right now, you would configure most likely somewhere CA, and then what you will do is provide, Cilium basically will automatically generate the required certificates. You can use Helm to manage the certificates and the CA or a subordinate CA in Helm, and then Cilium will based on that CA will generate the certificates for MTLS and the Cluster Mesh API server. It's documented. It's a multi-step process, so not just enable Cluster Mesh and you're done, but it's supported and it's working. But in the future, we're looking at making it more easy for you to use. Especially at scale, this can be obviously very challenging.
Perfect. Thank you very much.
Welcome.
Okay, any other questions here in the audience? Well, if not, then thank you for your presentation.
Thank you. Hope to see you soon in the workshop as well.